Alrighty, so exponential growth and decay, guys. So as a reminder, all right, we're looking at both growth and decay and also compounding interest and continuously compounding interest. These formulas will be available to you on the assessment, on your final. Okay, you're not going to have to memorize the formulas for this. All right, but we do need to go over them and understand how to apply them and when to apply them. So for growth, okay, you have the following formula. You got A equals P, 1 plus R to the power of T. And then what's the difference between decay? What's the difference between growth and decay?
One growing, one not.
That is true. One's growing and one is not growing. What else? What's the difference between the formulas? Huh?
The minus sign.
One is plus, growing is plus, decay is minus. Okay? All right? Remember, your A is your total amount, your P is your starting amount, your R is your rate. Remember, what do we got to do with our rate? We got to convert it to decimal. So what do we got to divide it by?
100.
Got to divide it by 100. All right, which we'll demonstrate and you will see. All right, and then T is the total time. Okay, our just a review of this, our compounding interest. All right, P is our principal amount. Remember, is going to be your starting amount. It's going to deal with what? What is compounding interest going to deal with? What's it going to deal with? Money. All right, so we got P is our principal amount. Our R is once again our interest rate. Now the N is the only new different thing. Okay, that's going to be monthly, weekly, bi-weekly, annually. Okay, remember those figures. How many weeks are in a year? Do you guys remember? How many weeks are in a year? 52. So if it's weekly, how many? What if it's monthly? What number is that going to be? 12. All right. Bi-weekly, 26. All right. There's 52 weeks. Half of that is 26. So it's important to know those ends. Okay. Huh? Our finals in 2 weeks. But you knew that. All right. Now, this continuously compounding. All right. We will go over. Okay. And I will walk you through it. All you need to do is remember they have the principal amount and you need your R and your T, the same as growth and decay. So let's jump right in, and you're going to have some room at the top of your paper to write this stuff down. So in this top part of your review sheet, all right, we're going to do the following. So it says you initially had 50 grams, all right, we're going to bring our calculator up. You initially had 50 grams of a radioactive element that is decaying at a rate of 6.35% per year. How many grams will be left after 5 years? Is this a growth or decay problem? It is a decay problem. All right, it flat out tells us this is, all right, going to be decay. All right, so if it's decay, we need to use the formula that is decay, which is P. We got parenthesis 1 minus R, parenthesis, raised to the power of T. All right, so let's get some of our values. What is our P value, guys? What is our starting amount? 50. All right. What is our R? What's our rate?
6.35.
6.35%. Can we leave it at that? No, we got to divide it by 100. All right, so let's do that. Let's do 6.35 and divide that by 100, and we get 0.0635. You're going to want to write that down. All right, 0.0635. Okay, got to convert that to a decimal. And then what is our T going to be, guys? 5 years. So now we can plug this into our formula. All right, we can plug this into our formula. So we have 50, all right, parenthesis, 1 minus our rate, all right, which is in decimal form 0.0635, raised to t, which in this case actually is not 10, but is 5. Because we got 5 years, all right? So everyone, let's plug this into our calculator, all right? We got 50, parenthesis, 1 minus 0.0635, close your parenthesis. And then how do we raise it to a power? What do we hit? The caret key. And we're going to raise it to the 5th power. All right, do that in your calculator, and let's see what we get. Nice. All right, 36.01. All right, so we can say our answer here is 36 grams. That's how much we're left with. Now remember, if it is a decay problem, your number is going to do what? It's going to get bigger or smaller?
Bigger.
Decay.
Oh, small.
Smaller. All right, growth will make it bigger. So anytime it's decay, it's important that we know the difference. All right. All right, let's look at the next problem, okay? And this is going to give us a good practice with the compounding interest and continuously compounding interest. So it tells us, you guys, we have $5,000 to invest for 10 years, all right? It says write the exponential function for both accounts and determine which account is better, all right? Account A compounds daily at an annual interest rate of 5.215%, all right? So we need to use what formula? Is it growth, decay, or is it compounding interest? Are we dealing with money?
Yeah.
Yes, we are. So it's compounding interest, right? There's your formula. Okay, we got A equals P, parenthesis 1 plus R over N, parenthesis, raised to the power of NT. All right, and now we need to answer the following. What are these variables? So what is our P, guys? What is our P? Good, 5,000. All right. What is our R?
5.215.
Yes, and if we were to do 5.215 and divide that by what? 100, you would get 0.5215. So we will actually record that. All right, 0.05 Okay. What is our N, guys? This is the tricky one. What is our N? What is the N?
It is in
What is it? It's daily. How many days are in a year?
52.
How many? Oh gosh. Did someone? 365 for daily. Remember, that's going to tell us what our N will be. All right, and then what's our T?
What the? You already did it.
Okay, use it. All right, what's our T? 10. Okay. So we need to plug this in, but let's rewrite it so we know that it all looks good before we do that. So our P, we have 5,000. We got 1 plus our R, which is 0.0635, which is 365, close parenthesis. All right, and then we're going to raise that to the power of nt, and our n is 365, and then our t is 10. Okay, so we need to plug this into our calculator. Now pay close attention to what we do here. All right, so you guys should be plugging this into your calculator as well. Practice is going to make perfect. We got 5,000, parenthesis, 1 plus 0.05215 divided by 365. Close your parenthesis. All right? And then we must raise this. So hit your caret key to 365. Now, when a number is right next to parentheses, what does that mean? What math operation is that? Multiplication. So we can also, you can put this in parentheses, or you can just hit the multiply sign, all right, and multiply it by 10. All right, and then you want to hit enter, and you will get your value. All right, now remember, this is going to be growing. So you want to make sure that your value is going to be bigger than what you started with. Okay, so we have $8,422. And how many cents, guys? And especially for rounding, how many cents? Good, 45 cents. All right, so there is your value for account A. Now we are not done. Now it says we are compounds continuously for account B at an annual interest rate of 5.015%. Now guys, we're going to get some practice with this. All right, this is going to be our PERT formula. Our PERT formula. So we have P, we have the E, we have an R, we have a T. All right, I will show you how to find the E here in a second. Okay, this is when something that says compounds continuously.
We never did.
All right. All right. So, what's our P? Guys, watch how easy this is. What's our P?
5,000.
5,000. What's our T?
T.
What's our R?
5.015.
5.015. So we got 5.015 divided by 100. Still doing the same thing. We got 0.05015. Now, that's just like a growth or decay. That's all you need is the 3 variables right there. Okay? Now, we're going to have to be able to find this E. Now, here's how you find the E. All right, here's how you use it. You do the second and then LN button. Now, wait. Let's plug in our stuff first. So, all right, our P is 5,000. Everyone type in 5,000 in your calculator. All right. Nice job, Keontae. All right. 5,000. All right, now we got to plug in our E. So let's do this now. Second LN. Where's that LN button? What's it right next to? Yeah, it's below log, right? It's right next to 4. It's below log. It's above that STO number. So I'm going to hit second LN. All right, and you will see that your E pops up, and it's already, the cursor's already flashing where the power would be. So we need to do 0.05015, okay? because it's R times T for our power, times 10. All right? We hit enter. And we get 8,255. And 98 cents. Which account is better, guys? Account A or account B?
Account A.
Account A. It's got a bigger value. So there's your win.